Hello, I am Serge Bellin, and we are September 24, 2020. I'm going to present you our greenhouse that we designed ourselves, and it's made from thermal window that we recover for free, and then the rest is raw material, insulation and everything. So it's a small greenhouse. It's a test to see if it can survive winter. We got a solar panel on top of it, 3 by 5, 300 watt, and that is enough to provide enough current for my Raspberry Pi that is running, that control many things, as well as a water heater when the sun is enough. So let's go to the battery power supply first. So let's go behind. So here I got the charge controller, and we can check how many voltage in the battery now. I got 13.8, and if I check the Raspberry Pi reading here, so let's refresh it, 14.1. Depend of the sun, 13.8, it's fluctuate. So 14. Oh, this is an old one. Wait. Okay, 14.1 now. Yeah, okay. 13.8. Okay, so not bad. Okay, so here I got my battery. So the battery is two battery gold card, 6 volt each, 200 amps. And I connect in series to provide 12 volt to the inverter, which provide me 120 volt. This thing is, yeah, it's good. Yeah. Okay, let's go inside by this way. So here's the inverter, and I got the yellow and blue wire that bring the voltage of the battery towards a voltage divider that will divide the current by 4, so the Raspberry Pi will be able to read 25% of the battery, and then once it read that, it convert, multiply by 4, and then you got to 14.1 compared to the charge controller 13.8. Yeah. Okay, and then this thing provide energy like in a home at 120 volt, and then this is where I got a water heater that I bought from China, AliExpress, $10. It's 100 watt, and this heater is depending on the voltage in the battery. I turn it on, turn it off. So let's go inside. It's hot here. So inside it's presently 28 degrees, as you can see here, and outside is much more fresher, 18.2 degrees, and my battery is 13.7. now it's more accurate. And I got the soil humidity. So the soil humidity is the soil sensor here. It's this thing here that I bought from Amazon, $10 for 3. But then later I bought from AliExpress. It come back to about $1.50 each. So take 1 month, 2 months to receive it, but cheaper. I'm not hurry. And then here we can see that there is many wire. So this one is for the soil sensor. This one here, the green, yellow, red, is for the thermometer outside. The white and blue here is for the door sensor here. So it show me if the door is open or not. Like actually on my phone it show me the door is open, and soil humidity is 100%. If we close the door, wait here, if we close the door, then it will show door close, because both the sensor detect the other one, and then it's a Hall effect, and then it's used by magnet, and then it I detect a 1 or 0, and then it give me a open or close. So this is how it works. And here the green and the white wire here is the one that I read from my battery, which is connected to my my inverter. So we'll go down here and I will show you the box that I made to divide the voltage by 4. So this is my inverter here, and this is my voltage divider that I made out of resistor. So I put 4 resistors in series of 1k ohm, so it divides the voltage by 4. And this is very important because if you don't, if you provide 12 volts directly in the Raspberry Pi, well, in fact to the ADC inside my box, which is using 5 volt, you're going to burn it, and the ADC will die, and even maybe your Raspberry Pi too. So you must not connect directly 12 volt to a 5 volt system. So inside is quite simple. You only have it's very easy. I solder 4 resistors in a series, and then I got the input from the battery voltage, which is connected to my inverter at the end here. And then here I take my reading to the Raspberry Pi, the positive and then the negative, and then this gives me what I read there. And then if I take a measurement here, if I take the measurement of I have to put my glass first, of what I should read on the Raspberry Pi, should be where the ground is and the positive is. So should be about 3 something, 3.4645. So this give me about 13.8 exactly, 13.8. Okay, so this is the demonstration of the voltage divider. And after that, if we check the inverter, this inverter is a good quality one. It's a pure sine wave guarantee, so it's not a cheap one. It's quite big, heavy, and expensive. And then this bring me 120 volt toward that power bar here, and then this is where I provide a current to my Raspberry Pi. And this is the smart plug. A smart plug is something that I will show you. Is something like this. Smart plug, I bought it in Costco. It's a Wi-Fi plug, but the current software that was on it when I bought it was from China, and then everything go towards China server, and then they take statistic out of you, and then localization, and then many things. So me, I erased the whole thing. I replaced with Tasmota software. I explain all that in my PDF, and why I do that also. I explain why, all the why, and then there is a link towards a German that explain everything about it, why we should do that, should be careful about that. So we're going to plug it back. So that smart plug here, based on my reading on the battery, I will decide to provide energy to this one to turn it on or turn it off depending on the battery voltage. So my water heater, which is over there, which is something I bought from China, from AliExpress, $10. It's a 100 watt, and it works on 120 volt. And then this thing will warm up the water here, and I use that as a thermal mass for heating the greenhouse nighttime. So I'm going to plug this back. Here it is. Okay, and now we're going to go back to the Raspberry Pi, which is over there, and I'm going to unscrew it so you can see how it is made inside. Okay, so I will remove it. So you can see the gas sensor here, the thermometer from inside, and then as you can see there is another a camera here, and no other hole, no screw, only the screw at the bottom to open the box, but the box is clean. So this is a prototype but I may sell it as it is also. Of course, the wire, I will make sure the wire doesn't open easy. I will put here by using something that I make it melt on top of it, like this one here. So this is a testing prototype, so I'm testing real life testing here in a real greenhouse. So okay, I don't need that anymore, only 2 screws. So now I'm going to open it, and this is live. This is running actually. And as you can see, there is a tons of wire. Okay, here my finger is pointing to the ADC. It's a 12-bit or 16-bit precision. I don't mind, it's okay, it's enough for me, for my reading, for gas sensor, soil sensor, and then the battery sensor. So so when I bring the battery sensor toward the ADC, I read 4 times less the actual battery. Then I multiply by 4 to give me the actual reading on the battery, as my charge controller show me. In the where the red LED is turned on, this is the gas sensor from inside, and here are my wire towards there is for the gas, and there is also for the thermometer on the other side here to read the temperature. We control a motor to open the door when it's too hot, or make a hole in the wall to open a trap and close it when it's enough fresh. And then the rest of it is 14 pin, and this thing is a Raspberry Pi 0 Wi-Fi, and I solder everything to make it work. So you got everything here: the door sensor, the soil sensor, the gas sensor, thermometer sensor, battery sensor, everything is there. And plus I can control a lot more things with a smart plug. Smart plug, I can have up to 50 smart plug, but I don't think I will ever reach that, because it's 50 smart plug, you can control 50 different things. That's a lot of things to play with. And if each smart plug can control something, that also means that Raspberry Pi can also decide to turn on, turn off based on door, if it's open or closed, based on battery. If it's over 14 volt, turn on that thing or turn off that thing if it's below. And well, I'm missing the screw now. Let's put this back. So all this is live, it's running inside now. So this I don't need anymore. So I put it back. Okay, everything seems okay. Let's check on the phone now. Let's check this way. We see our face here on the picture, and then it's running 21, 22 second, 25 second, and now we got 14.2 volt, the soil humidity 18, and then temperature outside not really moving. Middle of afternoon, so it's not moving very much. And this is it. Oh yeah, the smart plug here. Yeah, this is where I will decide that. You can see the greenhouse water heater, which is over there in the bottle, is not turned on, because the decision for that is based on the well, I can turn it, well, I don't want to turn it on just for nothing, but on my phone, if you check here, I can go inside the setting of that smart plug, which control the current on that heater is here. So as you can see, there is a lot of condition that you can turn on, turn off. Something can be anything: door motion detection, temperature, below, higher, whatever, humidity, the gas, the soil, the battery, and then we end up at the battery. So in my case here for the greenhouse, I decide that if the battery go lower than 13.5, I turn off that thing. And if the battery go over 14.5, I turn it on. Since it's off, I believe it went below 13.5 and never reached 14.5 again to turn it on back, because the sun is gone anyway, because clouds are coming. So this is it. This is how it works. So the smart plug. This is all my software and in C language that monitor that thing, and this is just the interface with the user like me on a web server that the Raspberry Pi is providing. So everything is working based on my own software, and that's it. That's all about it. So this is a very quick introduction to that box, which I call it the Papa box. I have also the Mama box, which is a box with less things inside. But the Papa box is the whole deal, the big deal. Everything is inside: the relay, the gas sensor, door sensor, everything. So this is the Papa box, and then all of that is running on the Raspberry Pi Model 0 Wi-Fi, which has only one CPU. So as you can see, it's running quite well, despite the fact that it's a little CPU, little board, $20 board. In fact, you can have it at $10 US if you live in US. And then here, the greenhouse, we are at the beginning. We did not start many things yet because we are still working outside on the real garden, but it's coming. And then we try to make it grow different thing as a test. For example, we have the common vegetable that we want to eat, but also we are making grow mango that we take from Costco, and then we take out the seed and make it grow. So they are growing now, and we'll see. And this one is what is this one now?
Hot chili.
Hot chili here, because my wife is Thai and she likes spice a lot.
Long bean.
Long beans. The long beans is something that come from Thailand. It's very long beans. It's very tasty. And here we got some apple tree, other mango here, and apple tree here. So this is the start of the greenhouse. We did not plant very much yet because it's not very cold outside anyway. In fact, we have to open the door every morning because it gets too hot here. So eventually I will try maybe to make something that opens itself, controlled by the relay there, when I detect it's too hot, to refresh the greenhouse daytime. So that's it. Thank you for watching.